In this section, we are going to learn about matrix application and cryptology, encoding a message and decoding a message that was encoded. We will examine a method of encryption that uses matrix multiplication and matrix inverses. Let us first define cryptology. Cryptology is the science of developing secret codes and using these codes for encrypting and decrypting data. So basically, cryptology is the study of coding and decoding messages. To most people, this is used to keep communications private. The protection of sensitive communications has been the emphasis of cryptology throughout much of its history. A cryptogram is a phrase or code that has been encrypted by a simple letter substitution in which the goal is to decode hidden messages. Cryptology involves the process of encryption and decryption. Encryption is the process which transforms the original information into an unrecognizable form, whereas decryption is the process of converting encoded or encrypted data in a form that is readable and understood by human or computer. Encryption and decryption require the use of some secret information. In this section, we will use the following correspondence wherein letters A to Z corresponds to number 1 to 26. A space is represented by 0 and punctuation mark is ignored. This is called character key. For example, the numerical equivalent of the word math is 13, 1, 20, and 8. To use matrices in encoding secret messages, our procedure is as follows. First, encode the word or messages numerically. Second, list the numbers in step 1 by column and form a square matrix. This is referred to as message matrix. If you do not have enough numbers to form a square matrix, put zeros in the remaining spaces in the last column. Third, select any square invertible matrix called coding matrix, the same matrix as the matrix in step 2. Multiply the coding matrix by the square matrix that expresses the message numerically. The resulting matrix is called coded matrix. Fourth, and lastly, write the numbers by column from the coded matrix in step 3 to write the encoded message. Let us have this example for encoding a word or message. Example, use matrices to encode the word math. Step 1, we shall express the word numerically. So we shall use these character keys as discussed earlier. As shown previously, the numerical equivalent of math is 13, 1, 20, and 8. Step 2. List the numbers in step 1 by columns and form a square matrix. The 2 by 2 matrix for the numerical equivalent of math 13, 1, 20, and 8 is matrix 13, 1, 20, and 8. This is our message matrix. Step 3. Multiply the message matrix by the square invertible coding matrix. In this example, let us use matrix with elements -2, 3, -3, and 4 as the coding matrix. Remember that when you encode message, you can use any coding matrix of your choice for as long as it is an invertible matrix, unless otherwise it is already stipulated as shown in the example. So now, we are going to multiply coding and message matrix. We have to remember that we cannot interchange the order of coding matrix and message matrix. This is because matrix multiplication is not commutative. The product of coding matrix and message matrix is called coded matrix. So our coded message or matrix is matrix -29, 43, -64, and 92. For our last step, we shall use the numbers or elements by columns from the coded matrix in step 3 to write the encoded message. The encoded messages are written or represented by number strings. For our given example, the encoded message is -29, 43, -64, and 92. Decoding is the reverse of encryption. It is the transformation of encrypted data back into some illegible form. To use matrices and decoding secret messages, our procedure is as follows. First, find the multiplicative inverse of the coding matrix. Second, multiply the multiplicative inverse of the coding matrix and the coded matrix. Last, express the numbers by columns from the matrix in step 2 as letters. Let us have this example in decoding a word or message. Use the coding matrix with elements -2, 3, -3, 4 to decode -29, 43, -64, and 92. Step 1. Find the inverse of the coding matrix. Since in our example, our coding matrix is 2 by 2 matrix, so we shall use the formula for the multiplicative inverse of 2 by 2 matrix to find the multiplicative inverse of the coding matrix -2, 3, -3, and 4. The multiplicative inverse of the coding matrix as given is 4, -3, 3, and -2. Step 2. Multiply the multiplicative inverse of the coding matrix and the coded matrix. We shall write first the multiplicative inverse of the coding matrix, then the coded matrix. We have to remember that we cannot interchange the order of these matrices. So multiplying these two matrices will result to matrix with elements 13, 1, 20, and 8. Lastly, express the numbers or elements by columns from the matrix in step 2 as letters by referring to the character keys. The numbers are 13, 1, 20, and 8. Using the letters, the decoded message is math.